Hello everyone. In this question, we are given that let integral of 2 minus 10x upon 3 plus 10x dx is equal to half times alpha x plus logarithm of mod beta sin x plus gamma cos x plus capital C. Then we are required to find the value of alpha plus gamma upon beta. Okay, so we have to solve this integral first and then we have to find the function in this form which is given. Okay, so alpha beta gamma will be the coefficients of this final answer after solving this integral. Okay, so let us start. We are given 2 minus 10x upon 3 plus 10x dx, right? So let us first split this 10x in terms of sin x and cos x. Okay, so this will become 2 minus sin x upon cos x by 3 plus sin x upon cos x, right? So after doing this, if we take the LCM, this changes to 2 cos x minus sin x, and it will be divided by cos x, but then the denominator will also be divided by cos x, so they will cancel each other, and in the denominator we are left with 3 cos x plus sin x, right? So this integral is of the form, this is of the form integration of say a cos x plus b sin x upon say c cos x plus d sin x, right? The signs of a b c d can be interchanged. Okay, they can be plus, they can be minus, these are real numbers. Okay, dx, this is of this form, right? So in order to solve this, the pattern is you have to say this is the numerator of x, right, by denominator of x. Both are functions of x, right? So if this is n of x, numerator of x, and this is denominator of x, then the substitution that is needed is the numerator of x should be equated to a constant a times the denominator of x plus another constant b times the derivative of the denominator of x. Okay, in other words, the pattern should be, since a cos x plus b sin x is the numerator, right? So a cos x plus b sin x should be equated with a constant a times this denominator. So denominator is c cos x plus d sin x, right, plus b times the derivative of this denominator again. So c cos x plus d sin x. Okay, this should be the first substitution. Okay, after that, doing the derivatives, we will find this ab, capital A and capital B, by equating the coefficients of both sides. Okay, so this is the first substitution that is needed here. Okay, so we will start with this using this method. Okay, so in our case, the numerator is 2 cos x minus sin x and denominator is 3 cos x plus sin x. Okay, just consider this part, this explanation as rough. Okay, rough work. So let us equate, let 2 cos x minus sin x be equal to a times the denominator was 3 cos x plus sin x, right? 3 cos x plus sin x plus b times the derivative of the denominator again, 3 cos x plus sin x. So after doing this substitution, we now have 2 cos x minus sin x is equal to a times 3 cos x plus sin x plus b times the derivative of 3 cos x will become minus 3 sin x, right? Plus derivative of sin x will become plus cos x. So in the right hand side, if I take all the cos terms and sin terms together, okay, we are left with the cos terms. First term will be 3a and here b cos x, so plus b times cos x, and all the sin terms together will give me a minus 3b. So a minus 3b sin x, right? A sin x and minus 3b sin x. Okay, so now we are going to equate these coefficients of cos x and sin x together. So we have 3a plus b will be equal to 2, and then this is minus or a minus 3b is equal to minus 1, right? So now we have to just solve for these two unknowns and two equations are given. So if I substitute this value of b will be equal to 2 minus 3a. So if I substitute in the second equation, this becomes a minus 3 times b will be 2 minus 3a, right? Minus 1. So on simplifying, this will become minus 3 times minus 3 will become plus 9a. Plus 9a plus a, this will become 10a. 10a minus this will be minus 6, right? Equal to minus 1. So we get 10a will be equal to, if 6 goes to the right hand side, this will become 6 minus 1, so plus 5. So we get a is equal to 5 by 10, that is half. Okay, this is the first constant. Now b is nothing but 3 minus, what was b? Oh, it was 2 minus 3. Okay, so b was equal to 2 minus 3a. So this now changes to 3a. A is half, so this is just 2 minus 3 by 2, so this is again half. Okay, so we have found these constants. A is half and b is half. Okay, so now we can substitute this in the original integral. Okay, so therefore the integral 2 minus 10x by 3 plus 10x dx now changes to, the substitution we used was the numerator is equal to a times, that is half times this 3 cos x plus sin x, right? So this changes to half times 3 cos x plus sin x plus half times the derivative of the denominator was minus 3 sin x plus cos x, right? So minus 3 sin x plus cos x, and there is no space for dx, so I have written it in a clumsy manner. So this is 3 cos x plus sin x. So now this integration becomes very easy. Okay, the original integral was this 2 cos x minus sin x, right? So after finding these constants a and b, this is the pattern now of this integral. Okay, so now if I just split this into two separate integrals, the first integral, the half will go out, and you see this term and this term are exactly same, right? So they will cancel, so this is just 1 dx. Similarly for the second integral, this is half times, this is 3 cos x plus sin x, and this is nothing but derivative, right? So this is 3 minus 3 sin x plus cos x dx. So you see, if I take this denominator to be say u, then this is du, right? So this is half times du upon u. So this is nothing but ln u, ln mod u, right? So this changes to half x plus half ln mod 3 cos x plus sin x plus capital C, right? So if I take half common, this becomes x plus ln mod of 3 cos x plus sin x, right? plus c. So I think this is the required format of our integral, right? So if we compare now, the we are comparing it with half times alpha x plus ln beta sin x. Okay, beta sin x plus gamma cos x, beta sin x plus gamma cos x plus c. Okay, so we are equating these two formats. So from here we get alpha is equal to 1, beta is coefficient of sin x is again 1, and gamma is coefficient of cos x, which is 3 here, right? So from here we need to find alpha plus gamma upon beta. So this is nothing but 1 plus gamma upon beta is 3 upon 1, right? So this is nothing but 1 plus 3, so 4 is the required answer. Okay, so this is the required answer of this integral. This was not so difficult. Okay, you just needed to know this pattern. If it is in this pattern of a cos x plus b sin x upon c cos x plus d sin x, then once you use this substitution, this numerator of x is a constant times the denominator plus another constant times the derivative of the denominator of x. Once you do that, you can easily find these constants a and b, which is what I have computed here. Okay, the constants are equal in this case, but they can be different also. And once you do that, you see this is very easy now. You get one exactly same, the denominator and this denominator, they cancel each other, and the other one becomes the derivative, so you get a log term, right? So this is the required answer. If there are any doubts in any steps, you can highlight in the comments. Okay, otherwise this is finished. Thank you for watching.